So this latest video is just going to walk you through the later half of Lab 11. So hopefully you have Lab 11 handy, you've got Code Warrior open, and you're ready to create a new file in Code Warrior. Before we get too far into this, I want to point out that you'll need to wire some jumpers from port A bit 1 to PB1, that's C4, and also PB2 or A2 to PB2. And you can see this here, hopefully right here on the board. So put those two jumpers in, and we're going to make use of buttons 1 and 2, and they're going to light up LEDs 1 and 2 in just a minute. So it would be handy to have that up front. As you look further down in the lab, when we get to the section on adding interrupts for buttons and modifying systicks, you're going to need to copy what's in here to a new file. You're going to have to create a new file and place that in your sources folder. Also, you need to read this addendum on the last page. Before we do that copying, I want to just point out that there are two other files that you need to place in your headers folder, and they are these ARM-C M0.c and .h files. You'll see that I have them here. There they are, and they need to be check marked. And if you don't have them, that's okay. Just go to Canvas and download them. They're available. And you also have to remember to initialize port A and wire these pins. So this is all in the addendum. I'm going to start by copying board tester and copy the important parts of this file, or these lines of code, into it. So here's the simple way to do it. Go in here, go find board tester. I'm right clicking and I'm going to copy, and then I'm going to go up to the sources folder and right click and paste it in. It asks me to change it. I'm going to change the name to Lab 11. Make sure you keep the .c extension. It check marks it for you, so that's a good thing. Make sure it's the only check marked file. Oops, we got another one here. Get rid of that. And then open it up, and it should just be your board tester program. Now what you're going to do is get rid of anything you don't need. So these comments, for example, we really don't need them. Let's get rid of it. You could add a comment that this is Lab 11 demo of interrupts of systic and port A interrupts. And there should be 2 R's there. We'll fix that. Oops, that didn't work. And as you go down through here, we're going to add some stuff in here. We want to keep the crystal oscillator stuff, but I just want to get rid of a few lines here to make this a little shorter. This turning on LEDs and everything is we want to keep that, but I just want to get rid of some of these comments. We need this. We're going to actually end up using only 2 of these, so I'm going to comment these out. I may bring them back later. And we're going to be using push buttons on these pins, or on these pins, but we need to put some initialization in for that. So I'm going to get rid of these 2 temporarily and substitute in the initialization for port A. So init GPIO A and we're going to use 4 and 5. No, 1 and 2. A1, comma 0 to initialize that. And, oops, move that over, semicolon, and then copy that and put a 2 here. We won't need this till the second part, but just getting a little ahead. We don't need any of this stuff, so let's get rid of this. I mean, if you wanted to do that, you could. We don't need any of this stuff, so get rid of all of this, and we're in pretty good shape. So what we've done is kept the things we need, and gotten rid of the other stuff for the moment. Now when you go back and look at the lab, you've got all this stuff, and it doesn't go in one place. It's got to go piecemeal into the file. You can do this a couple lines at a time. So something like this, copy it, and that needs to go up above main. So let's do that, like right here. Okay, and you'll see that there's some stuff you have to fill in here. So we want to turn on LED1. LED1 is actually connected to G12 or C12, and so we'll go manipulate that. And we want this to be a 12. Oop, did that wrong. It's C. 12 and there. And then the next line, the off, is again C12 with a 1. Remember, sending the LED a high turns it off. Put a C there. So we set up these pound defines. I've got 2 variables here that we're going to use in a minute. And then I go back to the lab and I grab the next section. And the next section has all this initialization code for these 2 functions. So I want to grab everything down to here and copy it. And I need to put this in here as well. So I'm going to really should drop it in like right here. And you'll see some warnings because things like this is not a legal line, so we'll get rid of that. I would like to clean this up a little and put a tab. I'm just tabbing over that section. Up here as well, I'm going to tab this over just to make it look good. Make sure you brought in all the curly brackets. Those look good to me. So we have the initialization for this, for the system ticker, and we have the systic handler right here. Down in here we have this line, which it doesn't like. So I'm actually going to leave that line there, but I'm just going to put some comments on it, and that'll clean up a lot of these warnings. I went in set this a little bit with the tab key. I inset this one. So now it looks like a normal program. And what else do we need to do? I just noticed this is going to give us trouble because we're using it here and it's defined here. So I'm just going to move those 2 up. I'm Xing them out of here, and I'm going to put them up here at the beginning. Should have left those grouped together. I'm almost done. I've got just a few more things to do. And when I go back to the lab, I'll see that there's a couple items in main that I need to deal with. Now, Here I've suggested you use some functions to deal with initializing the push buttons and the LEDs, but you already have that in here. That's this code. So we're going to leave that. I'm just going to bring these two functions in. Oops, gotta get it right. And then drop those in here. And they need to be before the for loop. So let's put it there. And that's it, because the lab says we're going to have nothing in the main loop. Let's bring that over to make the point. Everything's being done by initializing the parts of the chip and then expecting these functions called handlers to deal with them. So I'm going to go click and build the project. Again, you need to have those ARM files in the headers, otherwise you get a bunch of errors. I've got one warning here. I can live with that. So I'm going to download this. And we're ready to go. And it's useful to have the LED1 tick value here up and running. So if it doesn't come up, add it with a global tool. I'm going to refresh while running. I'm going to hit go. Let's go right here. And I'm going to push a button. And what you see when you push the button is that the LED turns on and it stays on for 5 seconds. And if I push it again and wait about 4 seconds and push it again, you'll see it extends the time. And that's important. That proves that something special is happening. I'm also going to press the button and notice nothing happens until I release the button. So these are all things you're supposed to note in the lab when you get this working. And if you were noticing, every time I push the button, the LED ticker starts up at 4,999. It actually starts at 5,000. It starts ticking down. I'm pressing the button, waiting a while. I'm going to push the button again, and you see it restarts at 5,000 and restarts at 5,000. And if I'm careful here, I can, again, I'm going to push it very slowly. I'm pushing the button, nothing happens. But when I release it, you can see the counter starts. And that's all part of the logic of the interrupt service routine, that when an event occurs here on port A, hit 1, A1, then it does this handler. The handler says load, turn on the LED and load the timer at 5,000. And we already know that SysTick is able to generate an interrupt once every millisecond, and when it sees there's something there in the ticker, it decrements it. When the tick gets down to 0, then it just shuts off the LED. And you see those two independent functions actually working together with a common variable, and it has the effect we want, which is to pulse the LED the right amount of time. So in the lab, you are going to demonstrate that. You're going to try pressing the button, and then you're going to do it with a second button. That's why we wired the other button to A2, from A2 to C5. And you're going to experiment with turning on the other LED, and I recommend you do it with a timing of like 2 seconds. Right here. And then you have this option of making it flash. That's interesting to do. It's a good quiz question, so you might want to try it. And the last thing to do is look up the edge triggering in the book, in the chip reference manual, and maybe try changing it to a different edge. because the hardware is there to do any combination of edges. It's just something to try. So give this a try. Make sure you do the part 1 as shown in the other videos, and you'll be in good shape. And then you can think about constructing this windshield wiper software using this button. This is a variation on what was in the hour exam recently. Good luck.